All right, welcome back, everyone. You join me once again at the cabin here this Friday evening. Um, but anyways, so yesterday in class, in the in-person surface mining class, we talked quite a bit about the project mind map, and um, we talked a little bit about how you may want to lay out a mine plan, things like that. So there were some questions that were brought up, and so I wanted to get back to the entire class with some more details about the project mind map. Um, and so here we go. First off, um, I neglected to add a couple of the outcrops. So coal outcrops up here along this boundary. So everything in here, has coal under it, uh, at least presumably. We're not doing the geologic core holes or anything for this particular project, but so we're assuming that there's coal all through here. And same down through here, right? So there is an outcrop on this lower side as well from the original mind map that I showed. So I wanted to put it both on here. 1,420 feet is the outcrop elevation. We're assuming that for the entire property. In real life, this is going to slope some, but I'm just doing this, for simplicity's sake, so that we can have nice, even numbers for at least some of the stuff that we'll be doing. All right. Now, I've taken about, I don't know, several hours over the last day or so, and I've tried to find supplemental material on contour and high wall mining for laying out, like your contour strip and that sort of thing. So I haven't found really anything on the subject. Um, so what you're going to get today is my viewpoint on the thought process behind how to determine how you might want to lay out your contour mine. Okay, and we're going to be looking at both this map, the project map, and then I also have another mine map from an older property to show and go over with you as well. So with that, until we can get in a guest speaker who's a subject matter expert in this area, this is what you're getting from me. And like I said, that's a thought process. And to bring up a little story, when we were at the scholarship dinner there before the coal show last week, um, after I had bid on and won the awesome cutout, and it's a huge cutout, water jet. It's got plywood, metal. It's this giant cutout of our mascot, a giant Great Dane, and he's wearing a hard hat, and he's got his cap lamp and it's backlit. It's really nice. Anyways, you know, I was being joked with that instead of writing $1,000, that I'd written $11,000. Okay, and so I very carefully explained, how it was written as $1,000, and jokingly, the response was, "Well, all you engineers think alike," and to some degree, that's true, right? My response was that you're not exactly wrong. We've been trained to think like this. So so think of it this way. I am basically going to try to tell you my thought process when I'm looking at how I may want to design a mine like this. Okay. So when we look here, the first thing that we are going to, consider is, how are we going to access the reserve, right? Where are we going to access it at? And generally speaking, that comes down to about two things, right? You want to access it in the easiest place. Easiest usually means cheapest, right? So you want to access it in the easiest place. However, sometimes you may be, for example, maybe you want to mine the best gold first or something like that. So you might be limited to where you can start based on quality. Okay, there's some other constraints as well, but where you're going to access the reserve, you have a road here. It comes to, right about this point, almost up on what will be the bench. And so you may initially think, hey, I'm going to start right here. Okay, you might be able to. But the first thing you need to know about where you're taking your first cut is, where am I going to put the overburden, the spoil from this, so that I can mine the coal underneath it? So where am I going to store it at? So with this particular property, you may decide you want to start somewhere else. For example, do you want to start over in here, maybe? You could build a new road, come over this way. It's near the property line, but there's some space here. Okay, you only have to be 300 feet or more away from a dwelling, unless you have a waiver. But from the property line, you can basically get right up on it. And keep in mind though that you do need to access, kind of behind the high wall, so it can be cleared off from vegetation, so the vegetation can't fall over. Keep that in mind. There is some space there, but it's operational and not necessarily because you can't come all the way to this line. You definitely can. I would definitely recommend a very good survey, a new survey to be made of this property. And secondly, I would consider, for my own sake, some amount of buffer distance here. Anyways, so you may want to start right here. Shoot this point off, and I'll talk to you about the advantages of starting at a point, or shooting the points off so that you can get some space opened up. It's not as steep as this topography on the sides, so you can open up quite a little area. Maybe store it here, depending on volume. Maybe you need to start a small valley fill and have that permitted. There's other options. Okay, here for example, you could shoot this point off, but then you have to decide. There's going to be somewhere you got to put this. Before you start, hauling back onto the same site using the haulback method that I'll talk about here in a minute. But you could shoot this off here, maybe put in a small valley fill here, or bring it back around and place it here so that you can get started. And then once you take off in one of these directions, there'll be places behind you to start storing your overburden, right? Using the haulback method, where you'll open up a pit, for example, and then you'll take that material back up here onto the high wall, fill up an empty pit, obviously leaving space for high wall mining as well. So you have to have some space opened up to do all of that at once, but you'll be dumping back, at some point, right? Because you're going to refill this, back to the approximate original contour. Moving to the Southern Reserve, well, first off, we have this fictitious deep mine that I now need to change the boundaries on because it now comes out past the outcrop. So I'm going to have to change that. So it's all within the boundaries of the outcrop here. So yeah, I'll change it. Then what we'll do is, normally you wouldn't mine all the way to the outcrop, but we have to make some sort of assumption here, and I'm considering that they basically tried to mine all the coal that they could out of here, that it's pre-law, and that they extracted probably around 60% of the coal out of this mine. That's what we're going to go with for the purposes of this project. Yeah, so we're going to change that. We'll just cut her off somewhere about here and make it that outline. So for high wall mining this area, or in contour mining as well, once again, you may want to consider a box cut. Here, less than 80 feet, to this contour line right here, you could just come all the way across, right? And then start, you could high wall mine some of this, either from the front or from this box cut, come around this way here as well, high wall mine this from, either direction depending on which way you're going, right? Anything else? So the outcrop, by the way, this is where the coal seam meets the sloping hillside, right? The hillside. So you have the hillside here, your coal seam's here. This is the outcrop, right? So everything in between these red lines, maybe I could hatch it also. That's the coal seam. Okay, that's where the coal is well, not necessarily in place, but that's where it is or used to be. So for example, on this side, once again, so this is the bench width, right? You have about a 40-foot high wall, and the bench that was mined around this area is the width of this sort of this blue hatch here. So like I said, we'll be taking more of this off. So they'll be moving this back. So both of these are going to have implications, with the stripping ratio, and sort of what reserves are still recoverable from these two areas, right? So hopefully that gives you an idea of kind of where we're going with this, how to start thinking about where you're going to start at, how to lay out this mine such that you're minimizing rehauling material. So yeah, both of these are going to have sort of impacts on what's recoverable, what's still left in place, how much rock you have to remove to access it, and that sort of thing. So with that, let me make this one last correction, and I'll get this published on the website as well in PDF format. And I'm going to print these actually both in 200 scale and 500 scale maps, meaning that if you were to print these on paper or look at them at 100% scale on a PDF reader, that your more detailed map will have a 1 inch equaling 200 feet as the scale, and the sort of other map will have 1 to 500, so 1 inch would equal 500 feet. So you can print those off. As long as you print them at 100%, the scale will be correct and accurate. I'll be sure that this is all, also written down in the narrative description of the problem. So, or I could put a scale on the map too. We'll see. But with that, hopefully this clears up any confusion out there, if there was any, on sort of where we're going with this, with the project, how to lay out your contour cuts and that sort of thing. The next map I'll show you also has a lot of high wall mining in it, so you can get an idea of those layouts as well. I know we've talked about them briefly in the past, but I'll be sure to point out on the map the features that we're actually looking at as an example. So I'm also going to show you another mind map of a relatively large surface mine in southern West Virginia. We're only going to be looking at parts of this. The northern parts, were mountaintop removal, as you can see from the hatched areas of what was mined. That's the Stockton seam. Green is the Kohlberg. So it was mined on multiple levels, but primarily, especially this area, mountaintops on what looks to be both seams. Maybe not there. I'm not sure. It's contoured in this area, and then the Kohlberg was extensively contoured. And this is what I wanted us to look at. Okay. Here, we see dates when things were mined, right? So you would have started your pit and your high wall miner roughly the same time, right? So as soon as you open up enough space to get it started, you would start. And so that was mined in April, this area right here. This area, much larger, was mined in May. And then we have 11-foot cutter head width. They even have the information on here. That's interesting. So June, July, August, and then we come back up here. This was mined in August as well. They extended the pit out of ways and mined this with a high wall miner. So remember when I said shooting off a point? Here's two examples of shooting off a point, right? So the contour comes out this way, so you get quite a bit larger pit area, and so you can open up a decent bit of space, get a decent bit of coal extracted early, right? Which bankrolls you into the future. So it's another concept that production is based on, right? You go get you get your panel turned, you get your pit started, you get your high wall miner started in the best place where you can make money the fastest. That way you're padding yourself towards the future. There's also the southern area down here. You'll see a lot more disturbed area from the contour strip. There's valley fills here. So there was more fill material that needed to be placed in this area. You also have the box cuts that I mentioned, right? So this area was stripped. So was this. They could have high wall mined in through here. They chose not to. Chose to cut a box cut in, and then high wall mine off both sides. Same on this side, except they only high wall mined off one side, and then came around the contour this way. Once again, longest holes first, right? So getting in the coal as fast as they could. Also, setting it up so, when they make the turn, the other holes come right back in this way. But if you did run into trouble here, you started having short holes, you could cut them off and then come over from this side and hit your long holes back in here again. So that's kind of the concept of putting your long holes in first. It also takes into account that it takes more time to mine a longer hole, so the advancement rate of the high wall miner is slower, which is good, so that you can get out ahead of it. Because a lot of times you're going to be getting pushed by the high wall miner because it's just capable of moving faster than you are with the advancement of the strip, right, the contour. So these are a few ideas of where to go with your surface mine MIET 312 class project. Okay, so with that, you've heard Dr. Sears' thoughts on how to conceptually think of laying out a contour, strip mine, and high wall miner projections. Okay, this information comes from my experience working in engineering, including surveying, permitting, and some of the layouts for these mines over 15 years ago at this point. So this is what we were doing back then. This is kind of how we conceptually thought about everything. And with that, like I said, as soon as we can get a subject matter expert in, I'd love to have a guest lecture on this topic so that we can, have a better understanding of what we're doing here currently in Central Appalachia when it comes to strip mines like this. So thank you, and we'll see you next time.